Let me just go on the YouTube, okay? Just give me a moment. I'll just start with there are lots of students. Okay. I'll greet you one by one. Just give me a sec. Is the screen visible to you all? Got it, got it. Now just verify me. I'm just changing the slide. You have to confirm it that the slide change is also visible to you. Okay. I think it's visible, है ना?
गुड इवनिंग सर।
गुड इवनिंग टू ऑल ऑफ यू। कैसे हो भाई सबके सब?
बहुत बढ़िया सर।
बढ़िया। मैं भी बहुत अच्छा हूँ यार। ये सही हुआ कि आज आप सबने टाइम पे ज्वाइन किया है, बिल्कुल ठीक है ना। इससे स्मूथनेस आ जाती है क्लास में। आप लोगों के लिए बहुत रिसर्च कर रहा हूँ मैं ये क्लास परफेक्ट कैसे बने, पीपीटी सही चलेगी नहीं चलेगी। लॉट्स ऑफ वर्क। अरे ये सर वाले ओनली 2 स्टूडेंट भाई। अच्छा सब कैमरा ओपन करो यार एक बार, देखना है सबको। सबके सब ओपन करो अपना कैमरा। मैं देखूँ तो मैं मेरे स्टूडेंट्स के फेस कैसे हैं यार। कितना तो हक बनता है ना मेरा। क्या बात है। प्लीज टर्न ऑन योर कैमरा ईच एंड एवरी वन। आई जस्ट वॉन्ट टू सी योर फेस। दोज हु आर टेकिंग इंडिविजुअल। अरे वेरी गुड। दिस पीएमसीडी जीएनवी VZM. Wow, lots of student in the class. टेक आउट योर नोटबुक है ना, और उसमें लिखना है सब कुछ। चलो अब जो कंफर्टेबल है वो ओपन रखे कैमरा, और जिसे लग रहा है कि नहीं यार मेरा फेस उतना अच्छा नहीं आ रहा अभी, थोड़ा मेकअप की जरूरत है, तो वो बंद कर ले अपना कैमरा। ठीक है। वरना कोई दिक्कत का विषय है नहीं। चलिए तो फिर स्टार्ट करते हैं क्लास, है ना। ओके, वेरी गुड। सो जो भी आपके रेस्पॉन्सेज होंगे ना, चलो इसी पे ही भेजना, जो अवंती लाइव करके आ रहा हो, अवंती करके आ रहा होगा ना मेरा नाम, उसी पे ही अपने रेस्पॉन्सेज भेजना, मैं देख लूंगा।
सर आप कहाँ से है?
मैं उत्तर प्रदेश मुजफ्फरनगर से हूँ भाई। आपसे बहुत ज्यादा दूर हूँ मैं, मतलब आपके दिल के तो बहुत पास हूँ, बट वैसे बहुत दूर हूँ।
सर असम से।
आप आसाम से हो? वाओ, यू आर आवर नेबर्स। तो आई थिंक वी आर गोइंग टू एंजॉय टुडेज क्लास ऑल्सो, as we have enjoyed the previous class. So my voice is pretty much clear to you and the screen is visible. No problem in that case. No? And very good, very good. वो जेएनवी अंडमान से भी। वाओ, ये तो अक्रॉस द इंडिया मेरी पहुंच हो रही है भाई। वेलकम जेएनवी पंचवटी। ओके, सो गाइस, मेरा नाम तो आप सबको पता ही है. माय नेम इज अरुण शर्मा and I'm taking care of your physics. Not in each and every class I have to told this, but lots of new students have joined today, so that's why I have to say it's my little introduction. Okay? And I'll be taking care of your physics numerical parts. Okay? So most of the time we are dealing with the numerical in this class, but how to solve that numerical is based on the concept that we have. Okay? So conceptual learning भी होगी इसी क्लास में. ऐसा नहीं है कि this is just like the entertainment class and all. This is a serious class and you have to be serious in this class. Okay? Because ultimately in your exam, when you will take any exam like NEET or JEE or your board examination, ultimately what you are going to, you will be solving questions. Okay? That is the ultimate aim. No? And in this class also we are doing the same. So that class is connected to the purpose that we are pursuing here. Okay? PM Shri, JNV Gadag. I'm very fine. Thank you for asking. How about you? So here we have 64 students. Okay. Let me give a task to you first of all. We are talking about the mood. And there is a scale of 1 to 10. Now you have to tell me what is your mood now. Is it 10, 9, 1 or 2? Just give me a second. Okay. Everyone, अपना नाम लिखो एंड अपना मूड बताओ भाई. ठीक है. या लास्ट क्लास का रिकैप भी मैं इसी क्लास में दे दूंगा आपको. डोंट वरी. वेरी गुड JNVS के. यू आर द बियॉन्ड लिमिट. आई एम आस्किंग यू टू सेइंग 1 to 10 and who is this? JNVSK is typing we are 100. Very good. Okay. So I hope we are good to go. So this is where we have left in the previous class. I am very fine. Thank you, JNV Gada. Thank you. Thank you. Okay. Okay. So I think we are good to go now. Yes. Yes, sir. Have you any problem? Please put down your. Okay. So now in this class we will talk about the general equations of motion. Okay. Now what is general equation of motion? In the previous class, when we are talking about the motion and its type, so we have also did a very quick recap of equations. Equation of motion for a uniformly accelerated motion. In that case, what we have seen, there are three types of equation that we generally deal with. Okay. And what are those? These are, I'm writing it here. V is equals to U plus AT. S is equals to UT plus 1 by 2 AT square. And V square is equals to U square plus 2A. So these three equation के बारे में we have talked in the previous class. Okay. Now these three equation is only restricted to the uniformity of the acceleration. तो इसके लिए इन तीनों इक्वेशन के लिए acceleration should be constant or zero. In that case only you will able to apply this equation. But what if the acceleration is not constant? In that case, what we will do? In that case, to resolve that case, we are here. Hi, Chitradurga, JNV Chitradurga. Hello. So now focus on what we are talking. So this three equation, equation of motion, you can only apply in the uniformly accelerated form. But what if the acceleration is not uniform? Acceleration is something that changes the velocity. What if the change of velocity is not constant? In that case, we are here with the general equation of. So what we will do? We know that velocity, just give me a second. Let me change the color here. Right. So we know that velocity is nothing but what? Dx by dt we can see. Dx is what? Change in displacement. And dt is what? Change in time. If you multiply this dt with v, so this will become dx into v dt. Now, dx is a very small quantity. Very small, very, very small. So in that case, what will happen here? If the quantity is very less, so you can apply it for. So that is why if we integrate the dx with a certain limit, now whatever the velocity is not constant, that is not our problem. Okay. That is why we are taking very small displacement for a very small period of time. So for very small period of time, there will be no change in the displacement. Okay. And we can say that the velocity is constant, but for a very small change. So that is why here we can apply the integration to calculate the overall value. Got it? Similarly, for acceleration, you can also do. For acceleration, you can also do the same. Okay. So acceleration is what? Change in velocity upon change in time. Again, multiply dt with a. So you can get integrate it with the proper limits. You will get the value of change in velocity over a change in period of time. Okay. Again, this is a very special case, as you have seen here. V1 to V2 VdV is equals to what? X2, X1 to X2 ADX. Now, how this equation has come? So you can say that acceleration we have as dv by dt. If you multiply this equation with ds, which is the change of, or we will take as it as x. If you multiply and divide dx here, change in displacement. So you can say that this, just a second. You can say that this dx by dt here, we can make it dx by dt. So this dx by dt is nothing but what? Velocity. So acceleration is equals to what? V, which is velocity dx by dt into dv by dx. One of the dx is remaining. Multiply dx here. A dx is equals to vd. Now integrate it. So you can get the acceleration in terms of displacement. So if in any question acceleration is given as a function of what? Function of displacement, function of a position. So for that case, you are going to apply this formula. If acceleration is given as a function of time, you are going to apply this formula. If velocity is given as a function of time, you are going to apply this formula. Okay. Now let's see in this question. So here's the question. Now two cars P and Q start from a point at the same time in a straight line, and their position are represented by xp, which is the position of car P, at plus bt square, and xq is equals to ft minus t square. So at what time do the cars have the same velocity? Now this question includes the concept of relative velocity also. So we will be doing this question just after this slide. Now let's just try to solve this question. This is pretty easy from previous question. The acceleration of the particle in meter per second square is given by. A is equals to 3t square minus 2t plus 1. So I have told you already that if acceleration is given in terms of time, as a function of time, as a function of position, so for that case, we are going to apply the general equation of motion. Got it? JNV Bijapur, please mute yourself if you are still unmute. Okay. Now, here, if you will see, the acceleration is given to you as 3t square plus, sorry, minus 2t plus 1. Okay. Now, if particles start with a velocity v is equals to 1 meter per second at t is equals to 1 second, then velocity of the particle at the end of 4 seconds. Okay, this is the simple question. Now we know that acceleration ko what we could write dv by dt. It's a very easy one. dv by dt we can write 3t square minus 2t plus 1. Okay. Here the question will say us to find out the velocity. So for that case, if we want to find out the velocity, we have to find out the expression of velocity. And we are going to find this expression with the help of acceleration. Acceleration का function given है, तो यहाँ से मैं velocity का function निकाल सकता हूँ इस फॉर्मूला की मदद से, इस कॉन्सेप्ट की मदद से. Acceleration को लिखेंगे dv by dt, no problem in that case. Now, what we will do? dv is equals to adt. You can apply the same formula where we have written in the previous slide. What is that? dv is equals to what? A dt. Now put the value of acceleration here, which is 3t square minus 2t plus 1 is equals to what? Into dt. And this is dv. Okay. Now, what are the condition that is given to us? What are the condition? The condition is given to us that velocity is 1 meter per second at t is equals to 1 second. Okay. So what we will do? We will apply the limit here that at t is equals to 1 second. At t is equals to 1 second, the velocity is what? Velocity is 1 only. At t is equals to t, velocity is what? Let's say v. Okay. You are saying that option B is correct. We will check it. Now, what you can do here? What you can do? This dv integration 1 to v will become v into limit is 1 to is equals to what? Now, you can distribute the integration inside. So what will be the integration of t square? It will be t cube by 3. And limits are t to 1. Okay. Plus, sorry, minus चेक करते रहना भाई, ठीक है. -2 into it will become t square by 2 integration of t, and limits are 1 to t again, plus 1 will become t, and integration is t to 1. Now here we have v minus 1 is equals to 3 and 3 will get cancelled out. It will become t cube minus 1 cube. Okay. Minus 2 and 2 will also get cancelled out. This 2 and 2 will get cancelled out. So it will become t square minus plus, because the limits will be a minus b type. And here outer side we have minus. So it will become minus a plus b. Similarly, it will become minus t square plus 1. 1 ka square is 1 only. And here we have plus t plus. Got it? Okay, JNV B is saying C. Only one time you have to answer. Got it? No need to rush about it. So here you can see that V will become T cube. This one and this one will get cancelled out. T cube minus T square plus T plus 2, because this minus will get here plus, and 1 is already present here, so 1 plus 1 is 2. Now at what time you have to find out the velocity? At 4. So put 4, so it will become 64. 4 ka cube is 64, minus 4 square is 16, plus 4 plus 2. Now this will become 12, and this 6 will cancel out, and you can directly write it as 10. And finally, now here in this question, there is a error in the answer also. Okay. So here you can say it will be 54. Okay. Got it? Clear है सभी को? Anyone? We haven't made any mistake na? Acceleration is 3t square plus 2t plus 1 minus 2t. Okay, dv 1 to v we have taken. So at 1, when time is 1, velocity is 1. It is v minus 1. Yeah, JNV Ukrul, please. Whatever the doubt you have, you can send it to me in the chat box. Let me just couple bone. Okay. So when we have integrated, it will become 3t cube by 3. We can take the 3 common out. It will become t cube. So we have put t minus 1 cube. Okay. Minus t square plus 1 into t. Oh, this mistake we have made. Here is the mistake. Mistake is what? It will be t minus 1. Upper limit minus lower limit. And we have taken it as plus. I have already told you that please take care of plus and minus. So this, what we have written here is 2. That will also not come. Okay. Let me just solve it again from here. Yeah. So this is v minus 1. It will become, when you put t is equals to 464 minus 16 plus 4 minus 1. This minus 1 will also get cancelled out. So finally what you will have is 64 minus 12. So 64 minus 12 is 52 meter per second. So option B is the correct. Okay. Okay, Yuri Vasu. देखो, what we have did in this question. What we have did in this question. We have an expression of acceleration. Okay. So I have told you when the acceleration is given as a function of time, you can apply this equation to calculate velocity. V dv is equals to integration of a dt, and you have to put the limit. Now, if you see, so here we are. If you see this, acceleration is given you as a function of time. Okay. So what we will do, we will apply this equation. dv is equals to a dt. Okay. अब acceleration is also given you in terms of time. So you have put the value of acceleration 3t square minus 2t plus 1. Now, what you have done? You have to put the limit also. So this is given to you in the question. At time t is equals to 1 second, velocity is 1. And we have to calculate the velocity as 4. T is equals to 4. Okay. So there is no need to put t also here. You can directly put 1 to 4. You will directly get the value at 54. Okay. 52. Clear? No need to calculate the expression of velocity and then put 4. You can directly put limit of time t is equals to 1 to time t is equals to 4. And at t is equals to 4, you don't know the velocity, so we have represented it by v. Now we have integrated. You know the integration of x dx will become x square by 2. Plus c is also there, but I'm not writing it. Integration of x raised to the power n dx will become x raised to the power n plus 1 divided by n plus 1. Okay? So when you put the value of n as 1, it will give you x square by 2. When you put the value of n is equals to 2, it will give you x raised to the power 3 by 3. Now it's clear to you. Yuri Vashum, is it clear to you now? Answer in the chat box. Okay. Now, this one, you can try this. Very good, Pratham. You can try this also. So in this question, displacement of a particle of mass m moving in one dimension under the action of a force is related to time t, and t is given to you. Have to just check the expression that is given to you. ठीक है ना? तो easily click करना mind में कि if this types of expression is given where time is dependent on something or position is dependent on time, so in that, yeah, Yuri, I'm talking to you also. Have you understand the concept that I have taught in the previous question? That's what I'm asking. Okay. So you have to identify where the position is varying with respect to time or the time is varying with respect to position. So at that type of question, directly put on the general equation of it. Okay. So here, this is given the displacement of the particle when its velocity is zero. Now we do not have velocity here. Okay. So firstly, we have to find out the velocity. Now to find out the velocity, what we will do? We need to calculate dx by dt. Okay. But there is expression given to us, but not in a proper form. So firstly, make it a proper expression. So t is equals to what? Square root of x plus 3. Now take this 3 this side. Free this x with the radical sign. Always remember. Okay. So here we can say that it will become t minus 3 root x. So x here will become, if you take the square root of both sides, taking the square root of both sides, this radical sign will be removed and it will become t minus 3 whole square. Okay. You can open the square also to make it easier. Okay. Make it understandable. T square, a minus b ka whole square is a square minus 2ab, which is 60, plus b square, which is 3 square is 9. So this is the final expression of x that we have here. Now we have to calculate where the velocity is zero. At that time, what is the displacement? Okay. Simply find out the velocity first of all. X is given to us t square minus 60 plus 9. So differentiate it with respect to x. Dx by dt is what? Dx by dt is what? 2t minus 6. Differentiation of any constant function will become 0. Okay. Now dx by dt ko we can write now. Dx is not nothing but the displacement again, and dt is the time. But we are not interested in the displacement right now. We are interested in the velocity. So this is the velocity that you are having here. V is equals to 2t minus 6. So you have to calculate the displacement where velocity is 0. This is the condition. So put V is equals to what? 0. 0 is equals to 2t minus 6. So t is equals to 3 seconds. So when time will become 3 seconds, the velocity will become 0. Okay. Now you have the expression here of x. What you have to do now? You have to just put t is equals to 3 in this expression. because t is equals to 3 is that time where the velocity will be 0. You can put it here or here, it's completely your choice, but I'm saying it's pretty simple to put t is equals to 3 here. So x will become 0 when you put t is equals to 3 in it. Now, what we can say that displacement here is 0. Displacement here is 0. Okay. So 0 is given in any option? Yes, option A is given as 0. Very good. So everyone understood it? No problem in that case. Okay. So I think all of you have got it, how to find out the answer of this question. सबको clear है ना? If it is clear to all of you, please put a yes in the chat box, each and everyone, and do it very fast. Okay? Do it very fast, quickly. Quickly give your response. If anyone is on mute, please put yourself on mute. Okay. So I think it's clear to all. Now we will talk about the graphs. Okay. This is also a very important kind of thing in straight line motion. So graphs for uniform motion के बारे में we will talk about right now. So uniform motion का graph draw, why we are drawing graphs? Because it's very hard to maintain the data in the tabular form. Okay. Suppose you have covered a journey of 100 kilometers. Okay. And at each and every hour you are changing your each and every minute you are changing your speed, and you are putting it on a table. Like this is your speed and this is the time. So there are lots of entry because in 100 kilometer, suppose you have traveled for t is equals to 2 hours, and for each minute you are taking your notes of your speed. So in 2 hours, mein how many minutes will we have? 120. Got it? 120 minute we have. Let me write it here. 120. Okay. 120 minute. So speed 1 here at 0.1 minute. Let's say speed is 10. So for that you have to maintain 120 entry. It's not feasible according to the tabular form. And it's very time consuming also. So what we have as an option? We have what? We have the graphs. In graphs में let me just show you the कैसे हम इसे टेबुलर फॉर्म से इजीली इस डेटा को ऑब्जर्व भी कर सकते हैं और ये हमारा टाइम भी वेस्ट नहीं करेगा. सो हाउ वी कैन डू इट? जस्ट लुक एट दिस. सपोज वी आर ड्राइंग अ ग्राफ ऑफ वेलोसिटी एंड टाइम for t is equals to 2 hours. So it's up to you. If you want to draw the graphs for 10 hours, it's up to you. You have to make one axis as time, one axis as velocity. Whatever the data you have, you can distribute it in a very equal form. Okay? There are graphs paper also. You can see that there will be equal distributions of line. Okay? So suppose you are taking this one gap as 1 hour. Okay? So this will be 1, 2, 3, 4, 5, 6. You can easily do that. And suppose here you have marked it as 100, 200, 300, and let's say the maximum velocity that you are having at that journey is 500. So whatever is the velocity you have, suppose at 1 hour you have the velocity 100, you can put a point here. For 2, let's say it's 200, you can put here. For 3, it's 300, you can make a point here. So how to make this point? Suppose at t is equals to 3 hours, the velocity is 300. So what we will do, this v will acting as a vertical axis and this t is acting as a horizontal axis. So you can put the point in the form of x and y. So x axis पे we have put time, y axis पे we have put velocity. So tv is the point. Okay. So we can say extend this line in the upper side and extend the line in front of 300 parallel to the x-axis. When these two lines intersect, that is the point. Time is equals to 3 and velocity is equals to 3. Okay. When you make this graph, connect these dots, you will have a variation that how the velocity is varying with respect to time. Okay. So all of you can do with the help of graphs. So graphs are very important. Okay. So for uniform motion, in the previous class, I have told you what is uniform motion when there is no acceleration present. Okay. If there is no acceleration, which means the change of velocity is zero. There will be no change in velocity. If the change in velocity is zero, then what we can say? If the velocity is not changing, we can say the velocity is kind of constant thing. Yes, Jane Vyasam, I'll repeat. I'm saying that uniform motion ka graph we are going to discuss here. In uniform motion, what we have seen, the velocity is constant. And why the velocity is constant? Because there is the acceleration is constant. Okay. So the value of acceleration is constant. Sorry, value of acceleration is zero. Zero. So when the acceleration is zero, and acceleration is what? Change in velocity. So change in velocity is also zero. So if velocity is not changing, which means it has a constant value. So that is why if you see here, the velocity time graph for a uniform motion will be like a straight line. Now at each and every time, let's say this value and this value of time, you check the magnitude of this velocity will always be constant at every point of. So this is, let's say, u. So this is constant u. ठीक है, क्लियर है सभी को? सभी आइडेंटिफाई कर लोगे ना? दिस इज द वैल्यू ऑफ सर्टेन, जो उसके पास पहले से जो वेलोसिटी है. सपोज अ बॉडी इज मूविंग विद 10 किलोमीटर पर आवर and it is moving throughout the journey with 10 kilometer per hour. So that 10 kilometer per hour is that length. Okay, clear? Now what is acceleration time graph? So anyone can guess acceleration time graph of uniform motion. What is the value of acceleration in this case? Acceleration is zero. Zero means there is no height on the graph. So that is why it will be coinciding on x-axis. So this graph is the acceleration time graph for what? For uniform motion. Clear? Now, there are two things you can extract from the graphs. First is the slope of the graph, and second is the area of graph. Area of graph. Okay. Now, the area and slope of the graph has a significance when you talk about the graphs of uniform motion. How? See, if you see this is the velocity and this is time, and suppose we are calculating it for t is up to this. So you can make a rectangle here. You will see a rectangle type of thing. This is the area under this graph. What is the formula of rectangle? It is length into breadth, L into B. Got it? What is placed in place of L? What is being placed in place of L? It is time and velocity. So V into T means what? Time is second and velocity is meter per second. So second will cancel out. So you have meter, which means ultimately the area of VT graph gives you what? Distance or displacement. So this area, you must take a note point here. Area of VT graph gives what? Gives displacement or distance, depending on this is a speed time graph or velocity time graph. Got it? Now, similarly, we can do the slope of the graph. So slope of the graph means slope of that line which is drawn in the graph. Okay? So how we can measure? Suppose this is a graph we have. Got it? So here is 2 point. Let's say this is point is x and y, and this point is 0, 0. So how to calculate the graph of this line? This is y and this is x. Y और x के बीच में ये ग्राफ है, तो इसका स्लोप कैसे फाइंड आउट करेंगे? So you can find out the slope between any 2 points given by applying this formula. Let's say this is x2, y2, and this is x1, y1. This is x1, y1. So what you can do? y2 minus y1 divided by x2 minus x1. This is the slope. Simply you can say what? The quantity that is in the vertical axis divided by the quantity that is in horizontal axis gives you the slope. So based on this information, if you try to calculate the graph of slope of VT graph, what it should be? V by T. I have told you. Value is on the vertical axis divided by value on the horizontal axis. So V by T here is what? Now, velocity by time gives you what? Acceleration. Acceleration. So simply, if you can see here easily, this is the velocity time graph, and it gives you slope of this graph gives you what? Acceleration. Area of this graph gives you what? Displacement. Now we can say that the value from this VT graph will give you the value of acceleration. Then how? Look. Suppose this is the line. We want to take up the slope. So this line only has a horizontal length, not the vertical length. Got it? So that is why this vertical limit is being constant. Suppose you want to calculate the slope between these 2 points. So vertical height is same for that. So if it is same, that y2 minus y1 that we will write in the upper side will become ultimately kya? 0. And if it is 0, then whole quantity will become 0, which means the slope of this VT graph gives you a 0 value. And that is what we are talking about. Slope of this VT graph is acceleration, and it is 0, which means acceleration is 0. So for uniform motion, the acceleration is 0. Clear? Now what you can take from this AT graph ka slope and area? What you can take with this AT graph ka slope and area? So area के लिए just multiply these two factors, and slope के लिए just divide these two. So when you multiply this to area is A into T. So AT is nothing but meter per second square, and it is T is time second. So it will gives you velocity. Okay. Now slope of this graph is what? A by T. Now this is not in your syllabus, but I'm giving you a hint that this is called jerk. The rate of change of acceleration is jerk. Okay. So slope of AT graph gives you jerk. Okay. This can be a question from any competitive examination. They can be asked about this. Now, what is the displacement time graph for uniform motion? So for uniform motion के लिए we can say that V is equals to u plus at, we are using this equation right now. But we know that acceleration is zero. So v is equals to u. Velocity is constant. If you apply this with s is equals to ut plus 1 by 2 at square, because ultimately you want a graph between s and t. So you have to find an equation that is relating s and t itself. So acceleration is zero for uniform motion. So s is equals to ut. Now here s is also variable because I have put it on the vertical axis. And time is also variable. U is what? U is constant. We have seen. So this is kind of, you have seen this equation y is equals to mx kind of, where y is the vertical axis variable, x is the horizontal axis variable, and m is the slope of that curve. So here the slope of the ST curve is directly given to you. What is that? The slope of ST curve is what? Velocity or speed, depending on which slope you are taking on. If it is a displacement time graph, जैसे कि इसमें given है, तो ये डिस्प्लेसमेंट टाइम ग्राफ है, तो इसका स्लोप हमें क्या देगा? वेलोसिटी. इफ इट इज अ डिस्टेंस टाइम ग्राफ, इट विल गिव्स यू स्पीड. नाउ व्हाट इज द एरिया ऑफ एसटी ग्राफ गिव? एरिया के लिए यू जस्ट हैव टू मल्टीप्लाई, आई हैव टोल्ड यू, एस इनटू टी. सो एस इनटू टी इज नॉट अ फिजिकल सिग्निफिकेंस ऑफ दिस क्वांटिटी. सो दिस इज नो फिजिकल सिग्निफिकेंस, नो फिजिकल सिग्निफिकेंस. ठीक है, क्लियर है? अब देखो, इट हैज सम स्लोप, सो दैट इज व्हाई दिस लाइन हैज सम वैल्यू ऑफ स्लोप. ठीक है, तो ऑलवेज रिमेंबर एस टी ग्राफ का कर्व विल बी लुक लाइक. क्लियर? नाउ आई थिंक दिस इज क्लियर टू यू. नाउ ग्राफ्स ऑफ नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन. ठीक है, विच मीन्स, सॉरी, नॉन यूनिफॉर्मली नहीं, यूनिफॉर्मली एक्सेलरेटेड मोशन, और यू कैन से नॉन यूनिफॉर्म मोशन. सो नॉन यूनिफॉर्म मोशन में वी हैव कवर्ड टू केस. First is when there is an acceleration which is constant, but when there is acceleration which is also not constant, that is the pure non-uniformity. Okay. So here we only talk about the uniformly accelerated motion, which means the value of acceleration here, the value of acceleration here is what? Constant. ठीक है, क्लियर है सभी को? Now for that only just a little shift. देखो, in previous case you will see acceleration time graph is at zero. Zero. There is no graph kind of thing in this. Zero graph are only this line. Velocity is little bit shift up, and distance time is linear. So you just have to move a little bit, just a one step. देखो वहां पे वीटी ग्राफ था इस तरह का, तो यू हैव टू मेक एटी ग्राफ. वहां पे वीटी ग्राफ कैसा था? इस तरह का था. लेकिन एसटी ग्राफ कैसा था? लाइन था. तो एसटी ग्राफ से पहले वाले ग्राफ पे शिफ्ट हो जाएंगे. सो दैट विल गिव्स यू वीटी ग्राफ. ठीक है, एटी ग्राफ कैसा दिख रहा है? उस वाले वीटी ग्राफ के जैसा. वीटी ग्राफ यहाँ पे कैसा दिख रहा है? उसके एसटी ग्राफ जैसा. ठीक है, अब ऐसा नहीं है कि ऐसे ही हाइपोथेटिकली याद रखेंगे अपने मन से, बिकॉज एक्सेलरेशन इज कांस्टेंट हियर, सो दैट इज व्हाई दिस ग्राफ इज बीइंग लाइक दिस. सो in that case velocity is constant, that is why that type of graph was there. So similarly acceleration time graph is there here. Velocity time graph के बारे में if you will talk about vt, so if acceleration is constant, which means this is a kind of y is equals to mx kind of thing. Velocity is variable now because there is some acceleration, so it can change the velocity, and time is also a variable. So again you have a linear curve. I'm not going to talk about again कि VT graph का slope will give you what and AT graph का slope give you. So देखो VT graph का slope, if you just understand it ना, if VT graph का slope if you will see, देखो is what? इज अ कांस्टेंट, किसी भी पॉइंट पे आप कैलकुलेट करोगे कांस्टेंट वैल्यू आएगी, है ना। इसका मतलब क्या हुआ, इफ वीटी ग्राफ का स्लोप इज कांस्टेंट and vt graph का slope gives you what, acceleration, which means in this motion acceleration is constant, and that is what happening here. ठीक है। Now st graph is a little bit, you have to understand it, that st graph gives you what, ut plus 1 by 2 at square. Now when initial velocity is zero, this is the case. ठीक है, initially there is no displacement because s is zero, so acceleration is starting from zero. ठीक है, sorry, displacement is starting from zero. So you can compare it with y is equals to ax plus bx square. So this is a quadratic equation. Quadratic equation, and the equation, quadratic equation का graph is parabola. Parabola. So you just have to remember the graph only. ठीक है. So here this graph is of parabola. कौन सा ग्राफ है ये, पैराबोला ग्राफ. ठीक है. So in uniformly accelerated motion, the displacement time graph is what? Parabola, non-linear. अब st ग्राफ का कर्व इज व्हाट, st ग्राफ का कर्व आपको क्या देता है, st ग्राफ का कर्व विल गिव यू, st ग्राफ का स्लोप s by t is velocity. So you can check it here. If you calculate the slope at this point, you have to draw the tangent. If you do this here, so at each and every point you will see that this slope is bit of change. This is theta 1, theta 2 and theta 3. So this slope is changing, which means slope is changing means slope किसका है, st ग्राफ का है, और st ग्राफ का slope क्या है, velocity, and velocity is changing because slope is changing, तो velocity is changing. ठीक है, which means कि यहाँ पे velocity constant नहीं है, and that is what we have seen. That is what we have seen. Velocity is not constant. Velocity is increasing with respect to time. Got it? So I hope that all the graphs are clear to you. Now, if anyone has any kind of doubt, you can ask about the graph. We can solve this question right now. So this is the displacement time graph, and do not make skip of any of these questions because these are the PYQs. Okay, previous yearly asked questions. This question is itself from NEET. Okay, the previous question that we have solved is from CUET. Okay, KCET. So do not skip any kind of problem, any of these. Clear है? Now this is displacement time graph that is given to you. In this graph there are two slopes. ठीक है ना? Two slopes means there are two motion possible here. दो motion हो रहे. So displacement time graph of two moving particle. Two moving particle. One is making angle 30, one is making angle 45. ठीक है? With the x-axis as shown in the figure. Okay. ठीक है. So यहाँ पे you have to find out the ratio of respective velocity. अब जिसने previous slide में जो मैंने बताया उसे समझ लिया ना ध्यान से, वो easily ये क्वेश्चन कर ले. डिस्प्लेसमेंट टाइम का वेलोसिटी पूछ रहा है आपसे, स्लोप गिवन. डिस्प्लेसमेंट टाइम का स्लोप क्या होता है, dt टाइम का स्लोप क्या होता है, dt ग्राफ का स्लोप. डिस्प्लेसमेंट टाइम ग्राफ का स्लोप होता है वेलोसिटी. वेरी सिंपल. वेलोसिटी इज व्हाट, स्लोप. अब स्लोप का एक और फॉर्मूला है, यहाँ पे थोड़ा एक्स्ट्रा दिमाग लगाना पड़ेगा, विच इज ऑल्सो गिवन इन टर्म्स ऑफ टेन थीटा. ठीक है. सो यहाँ पे मैं अगर इस 30 वाले को मान लू ए और 45 वाले को मान लू बी, सो वी कैन से दैट वी ए इज इक्वल टू व्हाट, टेन थीटा या टेन 30, एंड वी बी इज व्हाट, टेन 45. क्लियर है? नाउ व्हाट इज बीन आस्किंग, रेशियो ऑफ द रेस्पेक्टिव वेलोसिटी. वी ए बाई वी बी कैलकुलेट कर लो. अब देखो इसमें मेंशन नहीं है कि किस वाले को ऊपर रखना है किस वाले को नीचे. देयर इज ऑल्सो अ कंफ्यूजन. सो ऑलवेज रिमेंबर, जो भी क्वांटिटी, जो भी स्लोप आपको पहले गिवन है ना, जो भी स्लोप आपको पहले गिवन है, जैसे यहाँ पे 30 पहले से गिवन है, उसके बाद 45 है, सो यू हैव टू टेक इन द सेंस 30/45। ठीक है, सो 1030 इज व्हाट, 1/√3। 1045 is what, 1, so it is 1/√3, or you can say it is 1:√3। अब देखो ऑप्शन डी इज करेक्ट बेस्ड ऑन, ठीक है ना। सो एवरीवन, आई थिंक इट्स क्लियर टू यू ऑल। क्लियर है सभी को? एक क्वेश्चन और कर ले, वन लास्ट क्वेश्चन, क्या बोलते हो, बताओ। कैन वी डू वन लास्ट क्वेश्चन? आंसर क्विकली, क्विकली से yes and no, क्विकली। Only one yes has been received. Only one student want me to solve. Very good, Yuri. Have you understand it? Vashum, have you understood it? Any kind of doubt? I'm ready to help you. ठीक है, तो चलो कर ही लेते हैं एक लास्ट क्वेश्चन। ठीक है ना, एक क्वेश्चन कर ही लेते हैं, क्या ही जा रहा है एक क्वेश्चन में। ठीक है ना, वन लास्ट क्वेश्चन, लेट्स गिव इट ट्राई। dt ग्राफ पे ही बेस्ड होगा, ये रहा। ठीक है, dt ग्राफ पे ही बेस्ड, बताओ। बेस्ड ऑन द प्रोवाइडेड वेलोसिटी टाइम ग्राफ, केयरफुली, वेलोसिटी टाइम ग्राफ है। For an object straight line movement, determine total distance covered and the average speed between t is equals to 0 and t is equals to 20। अब देखो, दिया तो वेलोसिटी टाइम ग्राफ है, पर पूछ क्या रहा है, स्पीड, डिस्टेंस। अब हम पता है कि वेलोसिटी टाइम ग्राफ का जो एरिया होता है, एरिया ऑफ वी टी, v इंटू टी गिव्स यू व्हाट, डिस्प्लेसमेंट। बट हियर इट इज आस्किंग फॉर डिस्टेंस। हाउ टू कैलकुलेट इट? देखो, very simple thing I'm giving you। if it is asking for displacement, ठीक है, सो जितना भी एरिया डाउनवर्ड में है, जितना भी एरिया डाउनवर्ड में है, अपवर्ड वाले में से नेगेटिव कर दो, माइनस कर दो। इफ इट इज नॉट आस्किंग फॉर डिस्प्लेसमेंट स्पेसिफिकली, सो ये जो एरिया है प्लस ये, दोनों एरिया को प्लस कर दो, सिंपल। ठीक है, लेट जस्ट डू इट। देखो, अब ये क्या है, प्रॉपर शेप्स है, ट्राइंगल है, ट्राइंगल का एरिया क्या होता है, 1/2 बेस इंटू हाइट। ठीक है ना, आपको बेस भी गिवन है, हाइट भी गिवन है, डायरेक्टली कैलकुलेट कर लेते हैं अपर वाले, इस पूरे का एक साथ। तो बेस कितना है, 0 to 10, ऑलवेज रिमेंबर। देखो 5 से 10 होगा ना, तो बहुत से 5 to 10 में भी 10 ही पुट कर देते हैं। 5 to 10 मीन्स ओनली दिस 5, बट हियर वी आर कैलकुलेटिंग इट फ्रॉम 0 to 10, so it will be 10। So for first, I'm writing it here, 1/2, base is what, 10, multiply by, what is height? So height is this, height is what, 6. So this will be 60/2, which is 30. 30 what? 30 meter, because velocity is given in terms of meter. Always remember. Now for second one, 10 to 20, base will be same. Base will be same. And this height is also same. And I'm not taking -6, I'm taking +6. So this is also 30. Now suppose a kind of motion in which अब देखो, जैसे ही इसने 0 वेलोसिटी से शुरू किया था, मैक्सिमम 6 वेलोसिटी पहुंचा, उसके बाद अगेन वेलोसिटी घटते घटते क्या हो गई, 0, एंड देन अगेन इन द नेगेटिव साइड। तो ये मोशन पता है किस तरह का, दिस मोशन इज लाइक दिस, इट इज टेकिंग अ टर्न एंड रिटर्निंग टू द सेम पोजिशन, बिकॉज जाते हुए भी इसने कितना कवर किया है, 30, और आते हुए भी कितना कवर किया है, 30। सो इफ आई टॉक अबाउट यू अबाउट द डिस्प्लेसमेंट, व्हाट इज दैट, डिस्प्लेसमेंट कितना हो जाएगा, डिस्प्लेसमेंट इज 0, बट द डिस्टेंस कवर्ड इज 60। So this I1 plus this first plus second, you can have 1 plus 2 is equals to 60 meter. So 60 meter here is the what, displacement. नाउ हाउ टू कैलकुलेट द एवरेज स्पीड। अब एवरेज स्पीड के लिए क्या फॉर्मूला मैंने बताया था फॉर एवरेज स्पीड? वेरी सिंपल, बहुत आसान है। एवरेज स्पीड के लिए क्या बताया था मैंने, बताओ? टोटल डिस्टेंस, टोटल डिस्टेंस, नॉट डिस्प्लेसमेंट। टोटल डिस्टेंस डिवाइडेड बाय टोटल टाइम टेकन। ठीक है, तो टोटल डिस्टेंस बाय टोटल टाइम टेकन। अब टोटल डिस्टेंस कितनी कवर की है, अभी हमने कैलकुलेट किया है कितना, 60 मीटर। और टाइम कितना लिया है, तो 0 से 20 सेकेंड, यानी पूरा 20 सेकेंड का स्पैन इसने लिया है। अब यहाँ पे हम लिखेंगे 20, सो दिस इज कमिंग आउट टू बी 3 मीटर पर सेकेंड। ठीक है, अब आप लोग सोच रहे होंगे कि 3 मीटर पर सेकेंड तो गिवन ही नहीं। So you can also check the options. Options are not correct. Both the quantities are given in meter. ठीक है. So the correct option of this question is, you can match your answer 60 meter and 3 meter per second. How many of you are able to get this? Very good. Total distance by total time. GNVB, only one time you give answer, na? Why are you typing multiple times? So I hope that you have enjoyed today's session. Any kind of doubt, if you have, you can ask me right now. Otherwise, the lecture is being over. Thank you so much for being attentive in the class and being responsive in the class. I hope to see you in the next class. Till then, keep studying, keep learning, and keep motivating yourself. Okay. Bye bye. Take care.